Hello, everyone. Welcome to the panel on emerging data, digital data tools. My name is Yunkang Yang. I am a postdoctoral research scientist at the Institute for Data, Democracy, and Politics at the George Washington University. Today, we have four distinguished panelists. They are Deen Freelon, Mike Kearney, Yini Zhang, and Ryan Gallagher. So each panelist will have about 10 minutes to introduce themselves and also talk about the emerging digital data tool. And then we will have 20 minutes in the end for attendees to ask questions for the Q&A session. All right, so Deen, would you like to start first?
Yeah, okay. I don't think I'm viewable. Okay. All right, there I am. Okay, great. How you doing, everybody? My name is Deen Freelon, coming to you straight from Chapel Hill, North Carolina, where it's very cloudy. I'm going to get right into it. I have a digital tool to talk about, which we spent a lot of time developing. So I'm going to go ahead and share my screen if I'm allowed to do that. Go ahead and present that. And you can see my PowerPoint. I'm going to inflate that for you. The tool I'm going to talk about today is called PyGraph. It's a system that was developed in collaboration with the very excellent Drew Christ, who's a programmer who works here at the Center for Information Technology and Public Life. And I'll just go ahead and get right into it, what it does. So PyGraph, the Pi stands for Personalized Information Environment Graph, because pie charts are awful and no one should use them. So don't call it pie chart, it's PyGraph. It is it's a tool, a very specific tool with very specific advantages and disadvantages. I want to say that this presentation comes from a longer presentation where I talk about user-centric or user eye view approaches to social media analysis. There are a number of systems in this space. I think PyGraph adds a number of advantages and also disadvantages to the user-centric analysis of social media data. And so PyGraph has three basic components. The first is a social media app that collects user ID data via API. And so we pull all this data in from folks that consent to allow us to do that. We also have a database of over 3,000 web domains that are pre-tagged for political bias and factual content. These data come from Media Bias Fact Check, which I'll talk about in a little bit if I have time. And then we also give to our participants a survey that collects basic demographic, political, and media opinion data. This is from an opt-in panel that was gathered by the research firm Dynata. And so those are kind of the three components, basically tying survey data to social media data, which is not new, but we're able to look at users' timeline data in a way that few previous approaches have been able to manage. So PyGraph is a system that supports or could potentially support a wide variety of research projects. The one that we're going to do first, we are in the process of recruiting 1,000 US demographically matched users from Dynata. Each one fills out a survey and grants PyGraph permission to collect their data. Participants are compensated after permission is granted. What's really nice about this is that after they grant us permission to view their timeline, no further participant action or background software is required, which is really nice. Nothing to crash or go wrong on the client side, at least. Although obviously on the server side, things can go wrong. And of course, participants can opt out at any time via instructions on our website. Our plan is to track participants for a minimum of a year. And I'm happy to announce that as of an hour ago, we have 896 registered users. So we're almost at our goal of 1,000. I feel like a telethon person. We're almost at our goal. Keep on going, everybody. So we're really close. And we have had a few dropouts, but there haven't been too many, which has been really nice. So I want to show you what this looks like. And so let's see if I can pull up my, I'm going to try to, oops, those are my other slides. And so I'm going to pull this up. Hopefully you can see this. I think I've shared the entire thing. So this is my PyGraph. And so this is what the users see immediately after they have granted us access to their Twitter feed. And so what you're looking at here is something that we sort of give back to the users. In other words, this is sort of a very high level view of their social media feeds along two axes. The horizontal axis is ideology, with the left side representing left-leaning, the right side representing right-leaning. The vertical axis is something that Media Bias Fact Check calls fact quality. So the point here is actually not the midpoint. It's the fourth one down is mixed, which is set at the 0 point. Then we have mostly factual, high and very high, and below mixed, we have low and very low. And so you can see that the vast majority, also the size of each bubble represents the prevalence of that particular link domain within your own Twitter feed. So you can see that for mine personally, that I have a large number of link domains that are posted to my Twitter feed that are in the left-leaning and above mixed in terms of its fact quality. So if I mouse over these, you can see these. This is Slate. You can see another big one is Washington Post, Mashable, the Boston Review. Toward the center, we see WRAL, which is our local NBC, I think, affiliate, Ars Technica, New Scientist, Transparency International, JSTOR, MIT Technology Review. A bit sparser on the right-hand side, we see that we have the Wall Street Journal, London Evening Standard, Forbes, New York Post. Going below the mixed rating, we see some very tiny ones, very sparsely populated on the right, and below the x-axis, we have RIA Novosti, probably some kind of Russian thing. I don't know what that is. Daily Mail, down here, billionbibles.org. Not sure who posted that to my feed. And we also have Rumble and Competitive Enterprise Institute. So those are a number of items that we have here on this initial chart. There are some other, gosh, it's hard to do. There are some other details that are only accessible to the researchers on this project, which I'm happy to show you. So this is our little sandbox. We have some summary statistics here. This chart basically just shows the number of matched URLs per tweet by user. This basically just goes to show that as you go down the list of users here in terms of the total number, this is just, it's organized by the total number, or the average rather, number of URLs per tweet that are matched. This basically just shows that for most users, most URLs are not matched, and simply that means that they're not in the data set, which actually introduces a very interesting research question, which is, because media bias fact check is supposed to get most of the major political domains, what about everything else that it doesn't classify? Are people getting political content through ostensibly non-political domains? It's a major research area for us going down the line. I'm going to go over to some of these more interesting ones. This is average political bias by fact tier. And so this goes to show that for all of the domains that are rated very high, the average political bias is slightly left of center. For high, a little bit further left of center, mostly factual and mixed are all left of center in terms of their average political bias. When we get to low and very low, we're looking at getting close to the extreme right here. So this just goes to show something that I think most people in this area already know, which is that a lot of the disinformation that we're seeing does come from the right. And so this is basically just a reality check as far as that goes. And all this is based on the domains that are displayed to people who are participants in our project. Screen name statistics, I find these very interesting. These are the screen names that are posting to people's timelines who have the lowest average fact quality. Number one, the worst offender is Sean Hannity. MRC is Media Research Center, which is sort of a media watchdog that's on the right. Jay Solomon Reports is sort of a right-leaning journalist, or trying to portray that at least. Newsmax, Breitbart, Washington Times, etc. And then we also see high fact screen names. This is really cool. Roll Call, Reuters Science, Science News, Nature. A lot of journals here, JSTOR, Smithsonian, New Scientist, Lawfare Blog. And so we've got the good and the bad here. Last thing I'm going to show you real quick here is low fact hashtags. These are hashtags most frequently associated with low fact domains. Ultimo minuto, that means last minute in Spanish. I'm not sure what that is. A lot of place hashtags, EEUU, that's what the Spanish language abbreviation for the United States. Argentina, Godzilla of Truth, I don't know what that is. We also see things like OANN, One American News Network, Getter, America First, and a couple of other countries, including Peru and Colombia. High fact hashtags, AP Race Call, not sure what that is. Prep Your Health, Poli-Sci Research, it's always good, right? Unfold the Universe, Artemis, Open Access, Cancer Research. So a lot of research stuff really captures a lot of these high fact hashtags. I'm going to pop back in. I have a couple more minutes left, maybe one or two more minutes. I'm just going to talk a couple more things about media bias fact check. This is where we get our ratings both ideologically and in terms of fact quality. It has comprehensive coverage of many widely used English language news and political sites, detailed explanations of its ratings, and its data have been used in multiple peer-reviewed studies. And so we have pretty high confidence in the ratings provided by Media Bias Fact Check. And then just to wrap up, I know I'm running short on time. This is some of the rationale that we use for this particular approach. There are other types of user-centric programs that only capture what people click on, but we want to acknowledge with this project that people are affected by much more than what they click on, and also what people click on is a very small subset of what they actually see. Exposure to headlines, hashtags, and other inline content can shape people's views. We need to be wary of the illusory truth effect and confirmation bias, which can amplify this tendency over time. PyGraph as a system and other user approaches are complementary, and we're always looking for ways to improve it, and also for people who have ideas for how they would like to use this kind of data in their own research. And with that, I will close my mouth and allow the next person to speak. Thank you very much.
All right, thank you, Dean. That's fascinating. So I think our next speaker is Mike.
You said me, right?
Yeah.
Okay. I'll share my screen. All right. Well, hello. Thank you for having me. This is very exciting. I'm especially excited any chance I get to follow Deen. His work has always been a major driver in my own. So I want to take this opportunity to kind of talk at a more high level, both philosophically and practically, about digital tools. And I'm not going to get into a deep dive on any particular one, but kind of talk about trends, opportunities, and maybe future directions. So a little bit about me. My name is Mike Kearney. I got a PhD in communication studies from Kansas. I was an assistant professor at the University of Missouri for 4 years. And for the past 8 months or so, I've been a senior data scientist at Aware. I get to work on a lot of NLP problems, and that kind of inspire the remainder of the talk here. Some tools I've published and maintain include RTweet and Tweetbot 2, and then a bunch of other novelty R packages that have almost no scientific value at this point. Okay, so first, this kind of gets at perhaps like a pivot from academia to industry for me, but I've kind of accepted that all digital media platforms either currently use ML or machine learning, or they will use it soon, like whether or not they choose to. They will benefit from it or otherwise be influenced by it. And there's kind of no changing that at this point. And I don't think that's necessarily good or bad, kind of like most technology, it can be used for good or bad things. But what does kind of concern me about machine learning being used in digital platforms is that even having good intentions often leads to bad outcomes. And this is because we have all sorts of systematic biases that exist in digital systems, that kind of permeate the developers themselves, the organizations and institutions that develop and maintain them, and establish the evaluation criteria. There's like an endless number of ways that these models and these algorithms can introduce bias. And, systems they're replacing be more human manual processes. Also had a bunch of biases that we weren't always aware of, but machine learning provides, unfortunately, cover for some people because they believe that the machines are neutral somehow, even though we're not. So I kind of see the inevitability of machine learning as something that we can't really fight against, but that we can still promote responsible use of machine learning algorithms and hopefully have an impact on their more positive uses, or at least kind of reduce the amount of irresponsible good intentions that end up in bad outcomes. So kind of with this context in mind, I think a lot about how can we make machine learning tools and tooling related to NL or to machine learning easier and more accessible to researchers, particularly in the context of NLP. And so that's what I've been working a lot with recently, collaboration data between people in workplace contexts. This applies outside of it. So my background, mostly looking at Twitter data and other social media data, is very much applicable here as well. And so the kind of state of the art for modeling and natural language processing and computer vision and everything is deep learning. There's all sorts of different architectures and ways to implement it. They all tend to kind of rely on the same general approach to it. The complexity is implemented in different ways. But at the end of the day, they still are not that easy to do. And I say like that easy because there are some interfaces that promise that, in 5 minutes, you can train a deep learning model to classify the sentiment of IMDb posts or something like that. And while that is possible, you can do it all online in a browser. It doesn't mean that it's easy to build one from scratch about some idea you have. And that's, I think, kind of two things contribute to this most immediately to me. One is that the interfaces themselves are currently designed by computer engineers, and maybe not explicitly for other engineers, but that's functionally what's happening, is that we have a very technically savvy and highly capable group of people that can build these tools, but they don't spend a lot of time thinking about end users that don't have as much of a computational background or knowledge of how computer systems work. Researchers in particular are probably drawn to these tools because of their research questions and not necessarily because of their computational. There's a big kind of disconnect between the tooling that does exist and the abilities of the researchers to use it. An example of this would be type errors that are, for a researcher, completely trivial. For example, PyTorch or TensorFlow, for that matter, two of the most popular deep learning frameworks, will give you errors if numeric value that you give it is not specified as being on a CPU or a GPU. So that's like abstracted, that type of thing should be abstracted away, in my opinion, from researchers. You shouldn't need to know if a number is being remembered in your GPU or your CPU. You just need to know that it's a number. And that type of error is frustrating to researchers like myself, and kind of blocks us from developing tools. Engineers need those errors in order to build reliable systems. So there's kind of competing philosophies here that stand in our way of having easier interfaces. Another reason I think is that common examples aren't really useful. And this is important because a lot of these deep learning infrastructures change relatively quickly, and the only reliable documentation is usually by the actual company or the organization that's making those products. So one common example that is used for NLP is predicting the ancestry associated with names of people, and it uses a character level recursive neural net to do so. So character level means the actual individual letters in the name. It looks at patterns for how those show up in names, and then it associates the ancestry of them. So, I mean, it's there's a number of problems I would have with it as an example that researchers might be able to use, but most importantly, it's not natural language. These are names, and we're trying to predict ancestry. And that's the placeholder, the most common example I see for natural language. So it kind of immediately presents a problem where the example is not analogous to the problems you're dealing with. Fortunately, there are some interesting or promising trends that I think can make life easier for us. First is that there's been a trend to develop user-friendly interfaces that face researchers or end users. And then kind of treated distinctly from that are the backend engines that implement those models or those methods. So an example of this would be a tidy models framework in R or the Keras package in Python. Both of these allow the end user to specify a model like an outcome and some kind of predictor source of data. And then you can specify which backend engine you want. So which, if you want to use TensorFlow or Theano, or if you want to use a linear model or SVM or logistic regression model, whatever it is. So that's kind of a nice piece that allows us to kind of compartmentalize the different parts of the modeling process. And it allows us to bracket off some of those that might be of less interest to someone in an applied research context. That also means that if you design an interface for the modeling itself, you don't have to build in the design of the engine. You can rely on other tools to do that. And thus, engineers can work on the back end, and they can design it for engineers, and then engineer-friendly developers who have good minds for building research-based tools can build the front ends that communicate with those. And it seems like a lot more sustainable and promising way to develop. The other kind of recent trend is there's been more and more software libraries that offer low-level bindings to low-level languages and high-level languages. And this is kind of, until recently, the strongest argument to like use Python basically instead of Julia or R or SAS or whatever was that the bindings to like the NVIDIA GPU were kind of very tediously put together in Python or Python, and thus if you wanted to recreate it in R, you basically had to call Python. But that's kind of recently changed. The MLverse is a set of R packages that attempt to essentially recreate those low-level bindings, and it makes it so that there's a competing framework that might be friendlier, or at the very least opens up access to more people who have exposure to R, who should now be able to kind of more easily approach some of these deep learning infrastructures in a way where they could run a model in less than a day. Python Torch is another example of kind of the bindings that exist that has existed for a while, and then the emergence of Julia as a language that actually implements these things in its own language, kind of designed to do this on its own, is nice. It still probably needs a while to develop, but all these things I think are promising trends. So this is kind of where I think it kind of sets us up for opportunities to build more and more tools. And I think we need it because we need tools that kind of have researchers in mind when we build them. And more specifically, I think we need more high-level user-friendly APIs for big imaginative tasks. Deen, Freelon is a master of this, thinking of like, what is the big use that you want, a very simple and elegant way to implement it. I have a shout out here to something that I've done, which is the RTweet package, just specifying a username and asking for all of their followers, even if they have millions and millions. There's no reason why they can't be as easy as just a simple function call with less than 50 characters. It might take a while. You might have to wait a couple of days even, but there's no reason why it needs to. You need to write pages and pages of code to do something that is, at least at a high level, conceptually very simple. So I think we need more opportunities and more kind of big picture demands like that out of a package, and we need researchers to start to design those. But we also need to increasingly abstract away the engineering details that can bog us down, and that instead would allow us to develop more conscientious algorithms where we could focus more on the ethics of what we're doing, or we could, kind of optimize around or study more of the biases that exist in the training data or the algorithm itself. Yeah, so that's it, and I'll pass on to the next one.
All right, thanks a lot, Mike. I think our next speaker is Ryan. Ryan.
Hi, y'all. Just 1 second here. Okay, sharing. Good. Y'all can see my slides okay. Okay, so hello, thank you for having me. My name is Ryan Gallagher, PhD candidate at Northeastern University. And my research focuses a lot on online communication networks. And so to study those things, I develop methods for working with networks and text as data. And specifically today, I'm going to talk a lot about dictionary-based sentiment analysis. This is, a method that I think has a lot of potential, and it's also done very badly a lot of times. So I'm going to talk about how maybe we can kind of breathe a little more life into it and bring kind of our bearing as domain experts into this. And right, when we have dictionary-based sentiment analysis, remember what that is we have a dictionary of words associated with sentiment scores, and we calculate the sentiment by averaging across the scores and the frequencies of those words. So I just want to say, say we have a sentiment time series like this. And obviously in the time series, we have a highest point and a lowest point. And it's a really natural question to ask, something like, why is the first point more positive than the second point? And so if I tell you that this is the time series of the book Moby Dick, then all of a sudden this isn't that hard to interpret. If you don't know the story, it's a revenge tale against a whale that does not end happily. And so it makes sense why the start of the book is positive and the end is negative. But this kind of question comes up all the time in sentiment analysis. Anytime someone really compares any two sentiment values, why are they different? But what if this was a time series of emotion expressed in millions of tweets or news articles over the course of a presidential election or political podcast transcripts? This kind of really simple question of why is one text more positive than another gets much more difficult to answer, especially because we can't read all of those individual texts. So the big question is, how can we better interpret what makes a sentiment higher or lower between two texts? And in general, how can we interpret the word level differences between any two texts, even when we're not looking at sentiment? And so we can answer these questions using what I propose called word shift graphs. And word shift graphs explain how two texts differ at the word level. And so if you're looking at this, I know it can look really overwhelming, but in hopefully just 8 minutes, you should be able to fully interpret them. So everything I'll talk about is implemented in my Python package Shift Reader, which you can find on GitHub, and I'll circle back to this page right at the end. So let's come back to sentiment analysis, right? We have a dictionary where words are assigned sentiment scores, and so here I'm going to use a scale from 1 to 9 that measures how positive a word is. So words like pandemic and infections receive low scores, while other words like health and happiness receive higher scores. By the construction of this scale, right, words that have a score less than 5, intuitively are relatively negative words, and words that have a score greater than 5 are relatively positive words. And we know this because the middle value 5 is a reference value. It lets us qualitatively say which words are positive and which are negative. Without this reference value, we just have the words and the frequencies, right? So we're making use of this to interpret what different kinds of words are. We can use this notion of the reference value to enumerate different kinds of ways that words can contribute to the sentiment difference between two texts. And so we can ask, what makes one text have a higher sentiment than another? And so I think the obvious answer is, one text can use more positive words than another. But there's another way that a text can have higher sentiment. It can also have a higher sentiment if it also uses less relatively negative words. And so text can be positive not just because it uses more positive language, but also because it uses less negative language. And so on the other hand, we can ask what makes a text more negative than another. And so directly a text can use more negative language, but it can also use less positive language. And so altogether, these are kind of the 4 different ways that words can contribute to the difference in sentiment between two texts. You can imagine this doesn't even need to be, sentiment in a kind of positive, negative sense. It could be other scales like anger or surprise or things like this. There are many other dictionaries, but this is the notion to be able to kind of split words into different categories of, positive and negative contributions relative to this reference value. And these are the foundations we'll use for word shift graphs, which we'll represent using these 4 colored bars. So we have the kind of blue for negative words, the yellow for positive words, the deep shading for higher frequency, and the light shading for lower frequency. So now let's circle back to this word shift graph of Moby Dick that I showed at the beginning and walk it through it one step at a time. So what we have right at the top in the title is the average sentiment of the first and second halves of Moby Dick. And we see that the second half has a lower sentiment than the first, which we know makes sense because it's not a particularly happy story. Point here, though, is we want to know why it's more negative. We want to go beyond just these numbers that are 5.86, 5.77, which by themselves are very difficult to interpret. And so to actually interpret that sentiment difference, we're going to look at the word contributions. And so to the left, what we're going to do is plot all the words that contribute to the second half being more negative than the first half. And remember, there are two ways this can happen. A relatively negative word can be used more, or a relatively positive word can be used less. And so if we plot all these, then we can see all of the contributions. We see a lot of terms that make sense for an end of a sad novel, like die, dead, blood, killed, and drowned. These are all negative words that are used more in the second half of Moby Dick. But we also see some relatively positive words that are used less, like bed, voyage, gentleman, and the pronoun me. I think it's less obvious that these words would contribute to the change in sentiment. The word shift graph makes this more apparent. And now, not all the words in the second half contribute to its negativity. There are some words that give it positivity compared to the first half. And so these words make the second half not as negative as it could have been without them. And so we plot all these to the right. And remember, there are two ways that a word can contribute to the positivity. A relatively positive word can be used more, or a relatively negative word can be used less. And so we see a number of positive words that are actually used more in the second half, like whale, sun, life, and sky. And there are some negative words that are used less, like never, not, savage, and war. Okay, so now we kind of have the full graph in front of us. And remember, before all we had, if we were doing kind of the typical sentiment analysis that folks tend to do, is we have two numbers, 5.86 and 5.77. And otherwise, you'd have to kind of come up with a story with why they're different. It's easy in the case when literally we have the story of Moby Dick. It's difficult when the texts are any more complicated than that or large in volume. And the word shift graph literally shows us which words are contributing to the differences between those texts. And I also want to note, they alert us to peculiarities in our data and in the sentiment analysis that we might not notice otherwise. So notice, for example, the word whale is used more in the second half. The word shift graph shows that our sentiment analysis is saying this is a positive word. But in the case of Moby Dick, a revenge tale against a whale, it doesn't seem quite right that we would call that a relatively positive word. So if we considered that a negative word, it would contribute negativity in the second half instead. So this is a cue for us as researchers to reevaluate whether that word should be considered positive with respect to the dictionary we're pulling it from. We also see, words like coffin and cook contribute among the top words here. What's going on there, right? In the novel, these are both names. For example, about 30% of the time that the word coffin is used is actually referring to a name. And so this shows us some trouble with our text preprocessing. We might need to distinguish between uppercase coffin as a name from lowercase coffin as an object. And we also see, some of the top words contributing to the negativity are the words cried and cry. But when this novel was written in the 1850s, those words were often used to mean something more like yell or shout. So the sentiment range we have for words in the 2000s when the dictionary was made might not be appropriate for some of the words that were used in the 1850s. And so this is the power of word shifts. They help tell us what might be going on with the sentiment analysis. And you might see, these peculiarities as things that are bad with the sentiment analysis. What is good about the word shift graphs is that they make these apparent and they let us make choices about how we might handle them. So we might choose to reevaluate what the sentiment scores may be for them, or we may choose to drop them as terms altogether. And so, they tell us these issues about our data processing and measurement. And without the word shift graphs, all we would have are those average sentiment scores, and we wouldn't be able to say anything about them confidently. So it's really an interpretation method. So if you'd like to play with these yourself, they're all implemented in a Python package that I created called ShiftRater. It's on GitHub and it's on pip, and there's documentation that shows a cookbook of how to use it. I focus very heavily today on sentiment analysis here, because it's what all the cool kids do. And I know it's flashy, but with ShiftRater, you can actually do a lot more than sentiment analysis. So as I mentioned, you can do any kind of analysis that has word scores. It doesn't need just positive and negative. But even more than that, you can compare text when you don't have word scores at all. So if you just have frequencies of words and you want to understand how different texts are, there's also tools for that in ShiftRater. And so I highly encourage you to check those out because they are a much more scientific alternative to word clouds or something like that. And if you want to go into the details of this, we have a paper describing this. I tried to write it pretty accessibly, so it's kind of very didactic and tries to really walk from step 0 to step, understanding word shifts in their entirety. So thank you very much for your time, and I hope you find use for this tool.
Thank you, Ryan. Yini, I believe you are the next speaker.
Okay, thank you, Yunkang. Let me share my screen. So can you all see my screen now?
Yes.
Great, thank you. Hi, everyone. My name is Yini Zhang. I am an assistant professor in the Department of Communication at SUNY Buffalo. And today I'm going to talk about a tool which is called Memoration. And this tool comes out of a project that I did with my colleagues at UW-Madison, Carl Roll, and his then PhD students, Fan Chen, as well as a bunch of other folks, including Joe. So over time, this tool has evolved into like three interlinked components, a framework, a data set, and a public-facing website. So I guess a lot of good things coming through. So let me walk you through these three components one by one. First of all, memoration. I like to talk about memoration a little bit. So memoration, if you are not familiar with this term, it can refer to a flock of starlings. It can also refer to the action of murmuring, flocking. That is, all starlings can fly together and change direction, and thereby their formation together. And while doing so, they make low continuous sounds. So let me play you a very short video to illustrate, to show what memoration is. To me, I find this really stunning and mesmerizing. And the memoration framework really draws on this imagery of starlings flock together and changing formation over time. And this framework treats social media users as starlings that talk about current events in flocks. We define a flock as a group of users that band together via their network ties and their social identities, and they express their opinions in the network context. So different events can draw different amounts and types of reactions from different flocks. As a result, their formation, so to speak, changes over time. This figure here shows a conceptual illustration of this framework. And this framework includes 4 components. The first one is targeted sampling of users that you're interested in studying. And then the second component involves identification of different flocks. And the third component is about analysis of the opinions that emerge from different flocks. And the last component is about presenting the results on a daily basis. So basically, the first component and the second component can be performed, as needed. So in our case, we did these 2 things after a year, and the third and fourth components can be performed on a daily basis. So why do we need this framework? I want to talk a little bit about this. We probably have experienced this moment when we feel overwhelmed by the many different voices and debates on social media. So this framework, I think, can provide us a tool for us to better understand the political chatter on Twitter and to give more clarity to this chatter, because we think that the study of social media public opinion must go beyond the aggregate level and must foreground the different networks of actors whose views about various issues might be highly consistent internally, yet quite distinct from each other. So that's the first component, the framework. The second component is the data set. So we have collected I would say 2 data sets over time, actually. So first of all, we use a set of seed nodes ranging from journalists, politicians, pundits, activists in 2018, and we conducted network sampling of people who they followed and then we conducted a clustering and identified different flocks, ranging from like regional flocks, issue-based flocks, such as like climate change flock, like a gun control flock, and some like media flocks, like a flock of national political journalists, a flock of conservative media, and we also have some partisan flocks like Bernie Bros, like the Trump train. And then we downloaded their tweets on a daily basis using Twitter's search API. Specifically, we use Mike's R-Tweet package to do so, which is pretty neat. So basically, we treat each flock as a computational focus group, and then we collected their tweets on a daily basis. So we did it for 50 flocks from October 2018 to October 2019, and then at the end of October 2019, we did another sampling, and then starting from February 2020 till April 2021, we collected tweets on a daily basis for 24 flocks. So these data sets are available. We think our data sets have some unique advantage, particularly because we think that they might be more comprehensive than the historical data you can retrieve using Twitter's current academic API, because some users might delete tweets, they might deactivate their accounts, and Twitter might suspend accounts. But all those tweets and all that kind of content has been preserved in our database. But this raises the tricky ethical questions regarding whether we can use deleted data in academic research. So this is the second component. Moving on to the third component. The third component is more of like a public-facing tool. So it is a public-facing website that we developed at the beginning of this project. So this website provides a daily digest of the conversations from different flocks on a daily basis. And these flocks include, as you can see here, like finance reporters, venture capitalists and entrepreneurs, economists, and YouTubers, pop music artists, or like education related, tennis, climate change, so those flocks that we tracked and we followed over time. And it displays the level of activity of each cluster and the major events that they talked about and how they talked about those events, like the top, the retweeted tweets, the top used hashtags, and the top mentioned user handles. So this website currently is dysfunctional because it requires day-to-day maintenance, but we've been thinking about like a better way to present like our findings to the public, to journalists in general. So this is something that we can use more like thoughts on. That wraps up my presentation about Murmuration. I'd be excited to hear your questions about this tool. Thank you.
Thank you, Yini, for this great presentation. All right, so we have about 14 minutes or less for Q&A. So here right, so we have two questions in the Q&A box that have already been answered. And please feel free if you have any more questions. All right, so if we don't have any new questions from other attendees, I have some questions I would like to ask. So my first question is that what kind of suggestions that, this is a question for each panelist. So what kind of suggestions do you have for social scientists, for example, especially PhD students who hope to develop tools? Do you think that academia is supportive enough for this kind of skill sets? And if not, where can PhD students look for resources to develop the tools? Thank you.
I'll jump in and say that during a PhD program would be an excellent time to try to do that. One, because of the flexibility that the schedule usually affords, and you're surrounded by a bunch of resources that you might be able to pursue even independent of your own organizational affiliation. And two is that you can hopefully kind of force yourself or commit yourself to a project that requires the development of a tool for a course, or prospectus or something like that, where essentially you're committing to building something. You got to get something done, get a grade or credit. That's a nice kind of artificial, I guess a real deadline that you can impose on yourself to get that done. And it's certainly a time, like looking back now, where you're not going to have that much freedom to play around, to learn, and to develop those things. So, but at the same time, I don't think you're going to make a lot of progress just learning the theory or playing around with the ideas. You need to have a specific project in mind.
Let me go ahead and second that. I'm a real big fan of the old adage, necessity is the mother of invention. And so everything I've ever done has been to, in terms of building tools, has been to solve a particular problem that I have had. And, everything that I have that's public is just like the tip of the iceberg of things that I've actually developed. I've developed tons of things that I just haven't really gotten the documentation together for. I'm sure everybody else in this panel is probably pretty similar. And so on the how, you really have to have a problem that just nothing that exists solves. I also kind of want to address the why question. If you're a PhD student who really wants to go into academia, you might want to think about how much developing tools actually, quote unquote, counts for, when you go up on the job market and things like that. I remember when I was a PhD student a long time ago, well, longer than I think anybody else on this panel, one of my people on my committee said, well, you don't want to be known as a tool maker. And sadly, I am now known as that. So, thank you. I think that, you'll really want to think about whether, for example, I think that the reaction of the people that hire you is likely to be different if you're going into jobs or applying for jobs in academia versus an industry, where I think, tool making is very much looked upon a lot more favorably. So, it's all about how you distribute your efforts and what you spend your time doing. I can't really help myself, so that's my excuse. But you might want to be a bit more strategic based on the kind of job that you're interested in. So,
yeah, and I agree with all of that. I think all of the times that I've made these packages, I've also made packages for doing network models and for collecting Twitter data. A lot of what prompts it is it's something that I've had to do multiple times, and I just get a little sick of doing hacky little scripts, and it'd be nice to have a more reliable way of doing things. And I think the nice thing about trying to make a package for yourself, even if it's just for yourself, let alone releasing for other people, it makes you think a little more carefully about how you're writing your code. And I find my own code more reliable when I've kind of worked through it in terms of the form of code. And this all being said, I think it can be a little daunting to do this kind of code development, to write a package or to release tools for other people. And it's non-trivial, but I think it really is just something if you want to try to do it, just do it. There's not like you have to be this good to do it or something like that. It's really, for whatever tool you want to make, it is very accessible.
I want to echo what all the three panelists have said. So I think practice is really helpful. I took a data science class with Carl Rowe. That's how our collaboration started. So in that class, there were a lot of assignments that I had to do, and I really got interested in doing. So I worked away at my computer just to do all those interesting tiny assignments. And eventually I did, so one of my prelim exams is actually writing the code up for network sampling users. So that was quite an experience. So that prelim exam kind of laid a foundation for building the tool that we have right now.
Right, thanks. So we have one question from Marvin Steckler. So the question is, do you have thoughts on or struggled yourself with enabling long-term maintenance of packages, et cetera, institutional, et cetera? Not everybody can be professor, but not. Yes, I think this is a question about maintaining the package.
I'm happy to jump in on this one. I've been maintaining not a package, but a software service since 2008 when I was a PhD student, and it's still going. And so the way that I approached that particular issue is I had a very intensive, and I actually don't recommend this at all, so you can learn from this poor decision that I made when I was a grad student. But I had a period of very intensive development on it that lasted basically the first 2 years of its existence, when I basically crushed every bug that I possibly could find as quickly as possible. And I found out that like once I had done that, the rate of bug emergence really slowed down a lot. So basically, if you have the time and effort and interest, you can sort of do a lot of the work on the front end, and then people end up, I'm at the point now where the system, the last bug that somebody suggested about this is probably years old at this point, which is kind of nice given the fact that people use it every day. And so, one option is to just kind of, do a lot of intensive development at the front end. Unfortunately, the reason why I don't recommend that is because it probably reduced the total number of like actual journal submissions by at least one. We could spend so much time doing that, but that's one way around it.
I have so our tweet is approaching like 1 million downloads. It ruined my email and continues to. And there's definitely like open source, what do they call it, fatigue or something, where you're very excited initially to build the tool and to give it out, and then you kind of, it wears on you because you want to help everyone who is interested in using the tool, but at the same time, you're not necessarily approached by everyone as though you are a benevolent person that's sharing free code, and instead that you're the evil person responsible for making it difficult for them to get Twitter data or whatever. So it wears a little thin. There are, like in retrospect, I don't even think I would try to do something like that solo right now, because I would want to get someone else in there to deal with that with me. But you can't always have that luxury early on. There are like R Open Science is, I kind of pushed our tweet through that, and that was a major relief because it's an organization that kind of peer reviews the package and then kind of commits to having the ability to revise it and to maintain it. There's also a lot of continuous integration tools that are very easy to use now, where you can set up a unit test. So if you have a Python or R package that is looking up Twitter data for a specific user, you can say, I expect this to return Twitter data. And every time you make a change to the package, that will run in the cloud on multiple different types of computers across multiple different types of operating systems, et cetera, et cetera. And it will tell you if you've created any new errors or anything like that. So there's all sorts of tools that can help make that easier. But I think the best answer is to trick other people into using and helping you maintain that work.
I think, yes, I've also found it a little difficult to maintain some things longer term, because most of the code that you put out there, someone will find, errors with it. They'll hit edge cases that you hadn't hit. And I found, particularly even if you're a PhD student with a lot of time, the people raise issues at the worst possible time for you, like it's in the middle of your qualifying exams or something like that. I found something that helps a little bit with long-term maintenance is, and this requires additional effort, which is a little frustrating, but is to make documentation that's as clear as possible, and to make cookbooks or Jupyter notebooks that show people explicitly how to use it. It's helped me get a lot less emails about how do you do this thing, and kind of limit more of the emails that I get to I might have hit this error, rather than how do I do the simplest possible thing with this package.
All right. I have one last question. I think we're running out of time. We have about 2 or 3 minutes. So I know Mike and Ryan, you at some point in your career, you've decided to transition to industry. And I think for a lot of PhD students, they probably are thinking about the same thing too. If they also love building tools, but do not find academia to be a supportive environment for developing such skills, what would be your advice for them? And what would be the reasons, for you to transition from academia to industry?
I mean, hard for me to generalize my specific reasons, but I certainly think that I would want everyone who is considering it, who can develop software tools, just to know that there are jobs that are very similar to being a professor that are not in the academy. And it's not like a huge pivot in terms of like what your materials need to be to apply for that job. They want someone who has a good research mind, who knows how to conduct research, who knows how to build tools for research. And it might be in less research intensive use cases, but there's a market for that that's going to continue to grow, kind of like my theory of like, we're getting all these powerful tools. Now we need responsible people who can like introduce theory into these tooling systems. So I would just say kind of look for things that you could very easily apply to put your hat in the ring and then go from there.
Yeah, I'm still mid-transition. I'm still in my I'm finishing up my PhD program, but I'll be moving out of academia. I think so. I'm not sure I have a ton to say about this. I think if you enjoy producing tools, then I think probably there are a lot of spaces outside of academia that are amenable to that. And I think if you have kind of clarity about, if you're fortunate to have clarity about where you want to go post kind of PhD or post whatever you're doing, and you don't want to go towards academia, making tools, if you enjoy it, is a really nice thing that you can point towards. And I think it's something I've even undervalued for myself. I was thinking recently, wow, I'm really scared about the thought of like writing production code at like a social media company or something like that. And I had to kind of remind myself, like, I've written, 3 or 4 packages that are used by hundreds of people. Like, oh, maybe I can do this. Like, it's a nice little confidence booster. As one of the panelists mentioned, it's just a kind of way to practice your coding too. So I'm not sure if that's particularly helpful, but I think, as Mike was saying, there's a lot of space for people who do make these cool tools to thrive outside of academia too.
Well, thank you so much, Mike, Ryan, Deen, and Yini. And thank you everybody for coming to this panel. We will have another keynote by Joan Donovan tomorrow, and also another panel, data ethics. So I hope to see everybody there. So thank you very much again, and take care.